Okay, welcome to Computer Science E75. This is lecture 9, Scalability, and we've got just one more to go. So because of Thanksgiving, no lecture next week. You can essentially take the whole week off, at least from class, but the project is still due a couple weeks from now. And then our last lecture will be in 2 weeks, and we'll take a little week's respite, and then we'll rejoin in Maxwell Dworkin, the Computer Science building, for the CS E75 and E7 fair, which will be an opportunity to mingle with folks in the class, with folks in the other class, have some intimate cake, and delight in each other's projects. So any questions administratively about what lies ahead? No? All right, so today's about scalability and starting to ask questions, not unlike we did last week with security, about how you really think about future-proofing projects that you might work on and how you think about problems that arise, not so much when you just have a few dozen or a few hundred users, but if you actually are fortunate or unfortunate enough to have thousands of users that you need to actually handle. It's arguable, too, that some of these same threads will apply even in a smaller context if you just have a very resource-constrained environment, certainly making smarter design decisions with regard to your database setup, your server-side code, even your JavaScript can help create for a much better user experience. So I thought we'd begin with just a look at a few numbers here. Let me mute the screen just so I can tab over to a summary of a panel that took place 2 years ago now at a MySQL conference out in California. People who use MySQL and people who write MySQL tend to gather once or so a year for a conference to talk about primarily scalability issues, new features, and the like. And one of the most interesting takeaways when I happened to be at this one conference was a panel discussion that they had one morning where they had technical representatives from Sun Microsystems, Flickr, a site called Photolog, Wikipedia, Facebook, and YouTube, all sitting on like pedestals on stage, and the moderator was in turn asking them some fun facts about their various companies. How many such and such do you have? How many so-and-sos do you have? And so I thought I'd cite some of these numbers just to put into perspective what applications deployments might very well be like in the real world or even on university campuses where you have lots of users. So one of the first questions asked of this panel of engineers was, how many MySQL servers do you have? Now, Sun, for instance, answered first, and Sun Microsystems, just to run their website and such, how many MySQL servers do you think they claimed to have? Yeah.
Was this while they were still independent or part of Oracle?
This was 2 years ago, so I think they were still independent at the time. But if you'd like to give answers either way, we'll take both.
Were they virtualized?
They did not say. In fairness, this is very out of context. This was sort of their gut reaction. So if you're thinking big, don't think big here.
Is that a whole public website?
I believe so. That was the context.
100?
4. So they're using 4. Now, again, I take this one with a grain of salt because we don't know the context. The other ones will be a bit easier to wrap our minds around. But just to put this into perspective, how about Flickr? For Flickr, the website, it's a photo sharing website. Turns out they use MySQL on the back end for a lot of stuff. How many database servers might they use?
If you're talking disk space, I imagine they have big honkin' RAID arrays.
So we mean unique MySQL servers. So even though that might not be the only measurement here, that's interesting.
It doesn't?
166. So now we'll meet in the middle next time. All right, so 166. And we'll talk today about what it would mean to even have that many database servers and whether these are all copies of one another or if there's a more intelligent scheme you can implement, because in fact there is. How about, well, for some reason Wikipedia and YouTube took the 5th on that one and did not answer the question. How about Facebook, though? This was 2 years ago, mind you, before they hit the 500 million user mark. How many MySQL servers does Facebook have? And they actually, among all these sites, are really renowned for using such common technologies as PHP for a lot of stuff still, even though they have their own flavor of it now, and also MySQL for their backend. Ballpark figure, what do you got? 1,000's pretty close. So they reported 2008 having 1,800 MySQL servers, half of which are so-called masters, half of which are so-called slaves, which is a designed approach that we'll actually discuss today. Moving ahead to another question, this one about personnel. This one really just a fun fact, lest you think it takes an army of humans to design the databases that are running on these machines. Au contraire, Sun Microsystems at the time, 2 years ago, had 1.5 DBAs, database administrators. These are humans whose role in life is to focus on all things database. What might this mean? This might mean designing the schemas that are used to store data. This might mean writing what are called stored procedures or other database implementation details that are then exposed to programmers. In some contexts, it may very well be the case that the developers, like for instance us in this room, aren't actually the ones simultaneously designing the database and creating the primary keys and the like. That's left to someone who's more of an expert, or at least who owns that data, and there's more of a wall between developers and database administrators. So in this case, Sun claims to have 1.5 of those people. MySQL at the time, for some reason, had 1/10 of a person. They were going through some changes already at the time, it seems. Wikipedia claimed that it was their entire technical team that did their DBAing, which meant pretty much everyone wears different hats there. Facebook had 2 DBAs, YouTube 3 DBAs. So kind of exciting, frankly. If you like the database aspect of the course and you're looking to get your hands dirtier with this sort of stuff, realize that a single human these days can certainly scale. That'll be one of the themes today, his or her workout across many, many, many servers relatively easily these days. All right, something that's a little easier to wrap our minds around, perhaps. MySQL, for their website, had only 2 web servers at the time, presumably for backup purposes or the like. Apparently, the load that they get is sustainable with just a pair of servers. Sun Microsystems, for out of context tier 2, 160 web servers, interpret as you will. But now, perhaps more familiar to consumers, Flickr. How many web servers running some web server software did they claim to have, perhaps? So you visit flickr.com, and you might be sent to any number of how many servers?
You mean VM instances or actual machines?
You're asking me questions that I'm not qualified to answer, so I'm going to say yes. 244 is in fact the right answer. So again, ballpark figure. It doesn't so much matter the specifics, but that's an interesting number. But now fast forward to the all too familiar Facebook 2 years ago. How many web servers did they claim to have? And to define this, probably based on a hunch, a web server is going to be the piece of software sitting on some physical machine or virtual machine that's just listening for HTTP requests and responding to those requests. Doesn't necessarily mean that any data is stored on that same machine. Doesn't mean that the HTML that's being served up is from that machine. It just means it's handling all of these internet requests. How many web servers did Facebook apparently have 2 years ago? Keeping in mind that at the time they had 1,800 MySQL servers. Take a guess. There's really no wrong. Well, there's many wrong answers here, but not like it's a bad thing if you don't know.
I'll say 5 to 1, call it 9,000.
That's pretty darn close. Anyone? It's low, so you haven't disqualified yourself. Anyone want to? 20. You're overbid, so you're still winning. Anyone a little closer? 10,000 at the time, 10,000 web servers. And that was 2 years ago now, so who knows how many they actually have now. What was funny, and you can actually Google around for this and find the YouTube video of this panel session. It was actually kind of funny. YouTube at the time, whoever was representing them, I forget the fellow's name, pretty much was taking the Fifth Amendment on like every question, and really quickly did the audience wonder, like, what the heck are you doing on this panel? You won't answer any of the questions. And he was sitting next to a bunch of people who were being quite candid with their numbers. So another topic that will come up today, too, is that of memcache. Turns out that there is a tool called Memcache Daemon, that is, as its name suggests, is a memory cache. And it's wonderfully advantageous to use if you're generating a lot of dynamic content that doesn't necessarily change with every request. And so you want to cache the HTML that your PHP code or whatever spend so much effort gathering together, and then serve up just an identical copy of that HTML the next time around. Unlike, for instance, the web-based projects we've done thus far in PHP, where every time the user's visiting foo.php, you're re-executing or reinterpreting that code, you're regenerating the HTML, and then just throwing it away once for that individual user. The next time you hit reload, the same process happens again. So that'll be an opportunity for optimization today. So these companies some of them were using Memcache, although YouTube would not admit to it. To put things in perspective, Sun at the time was using 8 such Memcache servers. Again, the idea here being when their web servers generate dynamic content, they cache that HTML for some number of seconds or minutes or hours or days, whatever. Flickr had 14 such servers. Wikipedia, 79. And that's interesting, right? Because would you expect Wikipedia to be more read-heavy or write-heavy? Probably read. Definitely depends on personality, right? There's definitely some crazy people out there who it's probably more write heavy than read heavy. But certainly someone like me, for better or for worse, has never edited a Wikipedia article. I've been very read oriented over time. So it kind of makes sense that for someone like me, if there are other people like me, more than the writers out there, that more often than not, we just want to see the content. We don't want to change it. And if articles are not getting updated every single minute of the day, surely we can generate one version of a Wikipedia article and only regenerate that HTML with some PHP code or whatever the next time someone actually makes an edit, not just a read. So a prime opportunity for optimization there. Facebook at the time, 805 memcache daemons. So the theme, frankly, at this panel was anytime someone bid, Facebook just blew them out of the water with their answer at the time. And then let's see if there's anything else. So for those who take a particular fancy to this kind of information, I'll link to the summary on the course's lectures page after tonight. But they have other questions there, like what operating system are you using? Not necessarily that intellectually interesting, but kind of a nice curiosity. What do you do when a server fails? What's your crucial scaling technology? So realize if you like that stuff, there's plenty of juicy information in there that you might take an interest in. So we'll revisit some of these topics as we proceed to discuss tonight. So where can you go for more information on this? So I haven't read any of these cover to cover, but have certainly flipped through all of them. And if you are the type who likes some textbook references or just some interesting reading, these are some fairly well-reputed texts in this particular space. How you can design with scalability in mind. And what do we mean by scalability? Well, we'll discuss today sort of the glass ceilings that you'll encounter. For instance, if you only have a server that has, say, 1 gigahertz of computational power, that's only a finite amount of capabilities. And so you can only handle some number of users per second. And as soon as you start to exceed that number of users per second, things are going to start slowing down for that user or for any number of other users. You might be paying for a shared web hosting environment, in which case it's not your load that's really problematic, but it's other people's load that's impacting your users. And so considering how you might design your application using fairly cheap hosting plans in mind, but perhaps distributed over multiple such accounts or have redundancies across 2 providers, these are some of the topics that'll come up today and perhaps beyond if you're take an interest in this kind of thing. So there's generally 2 themes when it comes to discussing how to design your software better with scaling in mind, whether it's hundreds of users, thousands, or whatnot. So you can throw, frankly, hardware at it. Unfortunately, throwing hardware at it generally means throwing money at it too. But frankly, one of the easiest ways to increase your application's performance, either because you want to make it faster or because you want to handle more users per second, more reads per second, more writes per second, whatever your unit of measure is, well, if you find that things are slowing down or the machine can't keep up, well, what's the easiest solution, perhaps, at least for a software developer? Just put your same code on some other piece of hardware, right? Quite honestly, get more RAM, get more CPU, or just get a different server entirely, but don't go back to the drawing board having to rethink or rewrite any of your code. Just move it to a platform that can handle that increased load. And here, perhaps Moore's law works to our advantage, right? You don't necessarily, if your popularity of your project or site is increasing over the course of the year, well, thankfully, the machines on the market 12 to 18 months hence are probably going to be a little faster and a little cheaper and with more RAM, more disk, more everything. Unfortunately, this isn't necessarily a sustainable trend. And in fact, if you are trying to get the latest and greatest, what's generally the downside of buying the fastest machine out there, the most RAM out there, the biggest disk out there? Right? It's expensive. You tend to pay a premium, even in the consumer market. Right? If you've ever bought like an Apple product, there's essentially good, better, best, where best is not a huge deal better than better, really, but it definitely costs you more. And that's certainly the case in the enterprise market, where you can spend much, much more money just to go from, say, 2.86 gigahertz to 3.12 gigahertz. Now, you'd have to do the math for yourself to see if that really benefits your users and your application enough, but odds are you're going to be spending more and more as you ride this technology curve for every additional CPU cycle and or piece of RAM. There's generally a sweet spot a bit lower than that. But what are some of the things you can scale inside of a computer? So I've let you glimpse this here, but let's now see how well you retain. So CPU was the first thing on the list there. So what would that actually mean? Well, in theory, with some servers, you can just buy an additional CPU, put it into the otherwise empty socket on the motherboard. But generally, that's easier said than done. And so generally upgrading the CPU generally involves upgrading or changing the whole chassis, getting a different server altogether. But adding RAM is certainly an option. What about in the hard disk space? It's fine if you glimpsed some of these acronyms, but what are the different types of hard drives out there today? Yeah?
Well, I mean, the topology, the internal bus for a drive is typically fixed. I mean, you could change your card, that kind of thing. But generally, when people want to scale, they go to some sort of external solution with like a network array, you know, or an SAN, something, some off-board storage with a really fast link between your machine
OK, good.
and the off-board chassis.
OK, good. So just to recap, in the storage market, and this might not be something you're too familiar with having just used, say, consumer PCs or Macs or even Linux boxes for some time, realize there's a number of current technologies in use when it comes to storage. So persistent storage, hard disks and the like. The one that most of us have in our computers these days, if they're just a couple of years old, is a technology or acronym called what? SATA, so serial ATA. This is something that comes in both 2.5-inch form for laptops and also 3.5-inch form for servers and the like. And this is a technology that's pretty fast, up to 3 gigabits or 6 gigabits per second. And this is generally a technology whose drives spin at, say, 7,200 RPM, if you recall that number from yesteryear. But if you want to step up from that, in the enterprise market, there's generally a technology called SAS, Serial Attached SCSI. And so this is a technology whose drives tend to spin a bit faster, whose bus is a bit faster. That is, the bits can move back and forth more quickly. It tends to be about 10,000 revolutions per minute or 15,000 revolutions per minute. And so generally in the real world, when you're actually running a database server and you have a large data set, that can't necessarily stay resident in RAM the whole time, you really want to be able to retrieve data quickly from your disks. And so you might actually install into your server or buy a server with what are called SAS drives, because they spin faster and can move data back and forth more quickly. But there's always a gotcha. What's the instinctive gotcha with just getting something that's faster and better? So cost. And it turns out, though, in some servers, for instance, for the cloud.cs75.net, we use largely Dell hardware, at least for the servers in the cluster. And they have an interesting technology inside where we can put either SATA drives or we can put SAS drives. And we can even mix them because the so-called backplane inside of the server can handle both technologies. And so you can actually decide which one to use. We, for the cloud, actually use SATA drives because it turns out, too, that at least right now, SATA drives can be purchased in much larger sizes. For instance, 1 terabyte, 1.5 terabyte, 2 terabyte, maybe even 3 terabyte drives these days. Whereas SAS drives, I believe, max out around 600 gigabytes currently. So you pay more, they're faster, but you get more storage space for it. And for something like this, where we use students' home directories and such on the cloud, we just wanted more performance, more space, because frankly, we're not getting that many hits per second. Yeah?
For the CS75 cloud, did you choose to purchase your own hardware because of legal reasons or because of cost reasons? Did it actually make sense cost-wise to do that?
Good question. So for the CS75 cloud, why buy our own hardware as opposed to outsourcing to, say, a virtual private server or to the so-called cloud? So short answer, 2 years ago, several different answers. We've been using a VPS for some time for this course, a company called Servant, which I probably mentioned in week 1 or 2 of the class. And it was pretty good. We had a dedicated virtual private server. And it worked well, but we were paying for this on a recurring basis. It wasn't hardware we could control. And for instance, and much of the control of the device was out of our hands, which from our perspective was sort of a missed opportunity so that we could actually start playing, frankly, with our own hardware. So one of the motivations was to run our own cloud because we're sort of geeks and computer scientists, and because it's interesting, we can then tinker, we can optimize. Because so many of the students are either staff or students on campus, we decrease latency significantly by actually keeping the hardware on our own fiber optic network for the most part, gigabit Ethernet and such. 3, it's definitely easier in terms of privacy and policies and such, keeping all student data on campus in a locked room in our own building. So that certainly simplified some details. And those were kind of the big three, to be honest. That, and actually the biggest one, as I stare into the camera here, is bandwidth costs. So we can't afford, no one can really afford very easily to stream terabytes of information per month over the internet unless you have some third-party host who's really doing it for you, a la YouTube. And it turns out if we were to pay someone like Amazon, who has their own cloud or any of those services, we would be paying a fortune every month for bandwidth costs. Whereas at least on campus, it's amortized across the whole university, and we have a much bigger pipe than we would with a private provider. So that was a big one, too. OK, so those are the various disk considerations that we might have. Other technologies that you can start to enable when disk performance specifically becomes of interest. So there's this technology called RAID, redundant array of independent disks.
Well, I mean, they're still small, but solid state drives are starting to be, used, particularly if you've just got a small set of data that you have to do that.
So indeed, this is an interesting trend, even in the enterprise market now, where servers that end up on a rack somewhere in a server room, you can get servers with solid-state drives, SSD drives, which are already in some of our laptops, maybe even your desktop computers. There, too, there's generally a trade-off. They only come in a few gigabyte sizes these days, 128 gigs, 256 gigs, not terribly huge, but they are much faster. And so you're even seeing hybrid servers being released these days where you have a solid-state drive where your OS, for instance, would go, and then you have some mechanical drives like SAS or SATA where you would then put your data, your home directories, your databases. Certainly, this is a trend that will probably continue for some time, getting more and more storage space in SSDs. Even as case in point, even in the consumer market, to be honest, being a bit of a geek, my Mac Pro at home has a solid-state drive where I have my Mac OS system folder, my user folder, my desktop, just so I get super fast interaction and very low latency. But for things like my Word documents and video files and all that, those just go on my SATA drives. Yeah?
Is RAID really for performance? Isn't it more for reliability and redundancy?
Good question. Is RAID really for performance? Is it not for reliability and redundancy? Depends what RAID level you're using. So the one that's very compelling in the consumer market, and again, my own Mac Pro, is a RAID level called RAID 1, which is duplication of data. So you have not one hard drive, but two hard drives. And either thanks to your computer's BIOS or operating system or special expansion card in your computer, you can essentially tell your computer, anytime you save something to my hard drive, actually save it to both hard drives simultaneously. And what's really nice is that your operating system or motherboard then should be able to tolerate failures of one of those drives, whereby if one of them just starts clicking and clacking and otherwise dies, so long as the other one is still operable and spinning, you won't have redundancy anymore, but you will still have your data. And in theory, the computer should still keep on humming away. Hopefully, you'll get a little warning message saying, go replace the other drive. But that's what's really cool, too. You go out to Best Buy or online, you buy your new hard drive of identical or larger size, pop it into the computer, run maybe some commands that you need to run, and voila, a few hours later, all of the data from the still working drive has been copied over to the new drive, and you're back up to your true RAID 1 level. Frankly, as a sort of word of consumer advice, if you do own any desktop computers at home, or if this is something you might buy in the next year or two, absolutely look for a machine that supports RAID 1. It's just kind of a no-brainer to ward off the inevitable drive failures that might happen. So what are the RAID levels? So there's RAID 0, which is striping, whereby you might have 2 or more disks. And in this context, rather than writing data both here and here, you write some of your data here, some of your data here, and therefore it effectively takes half as much time to write out that data because half can go over here, half can go over here. So that's generally what's known as striping. And there's yet other RAID levels, for instance, RAID 10 or RAID 1.0, where you combine those two and get both the features of redundancy and also the benefits of performance. So on a database server, for instance, it would not be uncommon to get a somewhat expensive server that has all SAS drives, which spin at, say, 15,000 revolutions per minute, which are in a RAID 10 configuration, which means you need twice as many hard drives. So if you want, for instance, 5 gigabytes, if you want, let's simplify the numbers here. If you want 600 gigabytes of storage, you need one SAS drive, but then another SAS drive, and then you can stripe the data over the two of those by also introducing yet more hard drives. So in short, with RAID 10, you end up spending essentially twice as much as you might not otherwise, and you tend to get less space as a result, but you get super high performance and good reliability. And there's other RAID levels too. Frankly, in the cloud server, the physical machines we own in the computer science building, each of our servers that you know as the cloud had 6 drive bays. We have 6 SATA drives in there. Each of them is 1 terabyte, but we operate those in what's called RAID 6, which is one notch better than what's called RAID 5. And RAID 6 allows us to lose any 2 of those 6 hard drives to mechanical failures or whatnot, and the rest of the server will keep on running. So rather though than having 6 terabytes of usable space, we only have, if you're doing the math, 4. So we have to waste 2 terabytes of space, but what we get is the comfort in the middle of the night that we can lose not even 1, but 2 hard drives, and we don't even have to worry about it until, say, the next morning. I mean, so it's a nice comfort to have. OK, finally RAM. So there's more RAM, generally gives you the ability to keep more stuff resident in memory. RAM is faster than disk. RAM is faster than disk, which is certainly compelling in, say, database applications. The more of your tables you can actually fit in RAM, the faster you're going to be able to select, insert, delete, update, and the like. And there are yet other pieces of hardware inside of a typical computer that you might be able to tweak or choose features among when you buy some piece of hardware, but these are perhaps some of the biggies. But it's vertical scaling in the sense that in order to handle more load on your system, you just kind of keep going up and up and up and up, both in terms of cost, in terms of performance, but there's no real thought going into this in terms of the design of your software. You're really just throwing hardware at the problem. Unfortunately, you can't do this forever. What's eventually going to happen if you try to just vertically scale? Right? Suppose that your 3 gigahertz server is no longer handling your load because you've got so many applications on there, so many users on there. Right, so why not just buy the 4 gigahertz server? Or the 5 gigahertz server, right? In the real world, there's going to be some limits. And either it's going to be your pocketbook or it's just going to be the hardware doesn't yet exist. So at some point, you're going to have to go back to the drawing board and recognize, you know, damn it, we can't handle 500 million users on our pair of rack servers here. We actually have to retool and rethink this whole approach. So there's this notion of horizontal scaling. This is just a silly picture of a sexy looking data center, a little warehouse with lots of servers behind little plastic doors there. But horizontal scaling generally means don't buy the latest and the greatest and the fastest and the most expensive. Rather, buy a lot of stuff that's cheaper and slower and maybe even used, and try to design your software, design your website, design whatever it is you're building in such a way that you can spread it out across multiple servers, ideally in a way that if you lose 1 or more of those servers in the middle of the night, even if there was user data on them, well, it doesn't matter. Your whole system, your whole ecosystem is going to keep on running. And for instance, Google is very well known for this. When you hit enter into a Google search box, supposedly what happens is your query is not farmed out to just a single server, but often chopped up to multiple servers, all of whom do a tiny little piece of the work, then get back the answer if it's not already been cached very recently. And the result is that you get back is the result of many little worker bees doing their job. And you can actually implement some software like this in Spirit yourself. There's open source software called Hadoop, for instance, with which Hadoop, H-A-D-O-O-P, which is software with which you can implement something called MapReduce, which is generally in computer science or programming a technique of taking a problem, splitting it up into smaller problems that can then be farmed out. You can tolerate failures of some of those little worker bees because someone else can just answer the question, and then it's reassembled by the so-called master node. So horizontal scaling is generally the long-term solution. And folks like Facebook and any of these popular websites certainly wouldn't be where they are if they were buying every single year the latest and greatest, but rather were spreading their load across much cheaper commodity servers. In fact, if you ever visit Google in Mountain View or look at, I think, their Wikipedia article, you'll see that the very first rack that Larry and Sergey built supposedly was really just the shell of a rack, and each of whose rows had just motherboard after motherboard, all of which had as many hard drives as they could physically fit into it. Rather than go out and buy something super fancy and sexy like the equivalent of a SAN back then, they instead just went with as much commodity hardware that they could squeeze into some unit of space. And I think the silly story there is they were charged by their data center at the time not by the electrical usage, not by the heat outputted by their machines, but by the physical footprint that their servers occupied. So it was in their interest to just cram as much hardware into one place as they can. These days, the world has caught up with the internet and realizes you should bill based on other metrics as well. So as developers, what can you begin to do to make your code faster, even if it's just for a handful of users? Because even they certainly would appreciate faster response times than, say, 500 milliseconds. Certainly would be nice if we could whittle it down into a tenth of that. So in the world of PHP, it turns out there's some really low-hanging fruit. So one of the stupid things about PHP or most any interpreted language is that every time you visit foo.php in a browser, the web server receives that request, realizes the file name ends in .php, hands that text file off to the PHP interpreter, the equivalent of php.exe. It takes the file as input, does its thing, spits out a bunch of HTML, which is handed back to the web server, which then sends it back to the browser. And what happens the next time foo.php is executed? The same damn thing, again and again and again. So there's a couple of opportunities here. One is caching of the HTML output, but the first line of attack would be to actually cache the results of having interpreted that file. So even though you don't run a compiler yourself explicitly on some code, it turns out that your PHP text, your source code, is being compiled down into something called opcodes or bytecodes, sort of similar in spirit to what happens with just-in-time compilers for a language like Java. And it's those zeros and ones or near equivalents that are actually executed on the system, but unfortunately by default are thrown away when the answer actually comes back. So using some free and open source software, can you turn on opcode caching, whereby the server who's responsible for actually executing the interpreter will keep around the computational results of having interpreted that file the first time. And how you do this varies based on instructions, but here are some of the most popular. So one's called APC, eAccelerator, which I've used on one of the courses servers before. We've used Xcache before, the Zen platform, and I'm sure there are others out there. And relatively simply, can you turn one of these things on by tweaking some configuration file? And that's it. So by low-hanging fruit, I mean there's relatively little reason not to enable these things. Yeah?
Is it cached with session information as well? As the function input is both the URL and the session information?
No, so session information would still be stored via some other mechanism like /temp or MySQL database. So this is independent of the actual user input coming in. Post and get would still be handed to what's effectively the compiled code. So it's not done on a per user basis. OK. So that was some low-hanging fruit. But now suppose it comes time to, we've squeezed as many freebies out of our code as we can. Now it's time to actually start distributing our code across multiple servers. Well, this is easier said than done. So even for the course's cloud environment, right now we have a CDN server where all of the videos are served up for. But we also have another CDN server that's standing by that we could start routing traffic to. And also for the login servers, when you SSH to cloud.cs75.net, if you've ever run the hostname command or something similar, you'll actually see that sometimes you're on a box called login 0, sometimes you're on a box called login 1, and if we actually turn them on, you might find yourself on login 2, login 3, login 4. These are all different virtual machines that are configured all in the same way. They all mount, so to speak, your home directory, your files and folders, but they are in fact different virtual machines that typically are on different physical machines. Now, this is somewhat problematic because when you SSH to cloud.cs75.net, we have to somehow route your traffic from the internet, wherever you are, to one of these machines specifically. So we do this using something called a load balancer. And this is very much what the most high traffic websites use. Even Harvard, for some of its servers, uses for a couple of reasons. One is load. So we use this same cloud for another class of mine. And between the two classes, we have some 700 students who, surely the night before some project is due, are all trying to connect to the server at once. And so having multiple VMs available helps us with performance. Everyone gets a better response time. And two, if we screw up or if something goes wrong, or in the other class we tend to get a lot of infinite loops, if someone takes down the server accidentally, we don't want to be dead in the water until I wake up, for instance, or before someone else addresses the problem. We'd like the whole architecture to keep on running. And so load balancing can also benefit you in terms of redundancies, right? Why have one of anything when you can have two of everything, albeit twice the cost generally, but at least then you can hedge against failures of that sort. So What does it mean to load balance? Well, here's just a generic picture where you have some user at the top there. They're connecting through the internet, as depicted by the cloud there. And then you've got this little black box called a load balancer. And behind that load balancer might be, say, 3 different servers. We talked a moment ago about SSH. More generally these days, it's some web server. So we've got www1 and 2 and 3. So that begs the question, how do you implement this black box? And you might notice the little moniker there, round robin counter. Well, round robin in general means the first request goes this way, the second request goes that way, the third request goes this way. And you can imagine more intelligent schemes that actually takes into account who that user is. But round robin generally just says, you go here, you go here, you go here, sort of a fair queue if you go to CVS to check out, pick a different line. But how do we implement this black box called a load balancer? What do you think some of our options are?
Keep a counter and increment it each time, and then send it to a different server each time, depending on what the value of the counter is.
OK.
Each 10 users is assigned to the mod n machine.
OK, so that's true. But then let's be a little more technical. What is this machine actually doing? So maintaining the counter is probably pretty trivial. But how does one machine receive a request, check some counter, and then send that same request to another server? What are the options here? Yeah?
DNS.
OK, so DNS would be one of them, right? Even back in lecture 1 of this class, did we talk about creating A records and CNAME records? For your projects, you created CNAME records. But recall, we did discuss A records, whereby you specify the specific IP address that some host name or domain name maps to. So let's come back to that in a moment. Yeah?
Virtual IP addresses?
So we could use virtual IP addresses. And what would that mean exactly?
Well, you got anybody that wants to get to 1, 2, or 3, the IP addresses of those machines basically has to be hidden from the client. So the load balancer might have its own IP address that it knows when it receives it. It knows it can map to 1, 2, and 3.
OK, good. So this is actually the approach we currently take with cloud.cs75.net. When you SSH to cloud.cs75.net, that actually leads you via TCP/IP, the Internet Protocol, to a virtual machine that we call our proxy. And this is just a virtual machine running Linux, but also some special free software called HA proxy, high availability proxy. It's actually relatively simple to configure, just a simple text file. It's running all of the time. And what it's doing is listening for TCP connections on a few different ports. One of them 22 for SSH, one of them on 80 for the web, and then we have 443 for SSL. And I think at the moment those are the only 3 that we have open. So if you look up the IP address of cloud.cs75.net, that will map to not login 1, not login 0, but rather to this so-called proxy device. This is just a Linux machine, again, running this HA proxy software that itself implements the idea of this round-robin counter. That's actually a bit of a white lie that I'll fix in a moment. But this software allows you to make an SSH or an or more generally, a TCP connection to itself. It then realizes, all right, this user wants port 22. I've got 2 VMs that provide port 22 services called login 0, login 1. And it chooses, say via round robin, to then itself make an make a TCP connection to login 0 or to login 1. And so essentially you have a tunnel of sorts. It's not a VPN because it's not doing any encryption. It's just creating a TCP tunnel for my traffic to go through this black box and then get routed to one of the individual devices. I then get a response from that device, whether it's the login prompt or my home directory, or in the case of web, it's the actual HTTP response. And the response just goes back through that same connection. Now, what's the upside of this? Well, if we ever need to take one of the VMs out of rotation, for instance, right now, there is no login 1. We took it out of rotation because we want to upgrade the amount of RAM in the physical machine that VM is on. So essentially, a couple days ago, we took, so to speak, login 1 out of rotation. We edited the load balancer's config file, and we said, no longer should you send anyone to this particular IP address, because these guys here have private IP addresses. Much like your home routers give you addresses like 192.168.whatever, essentially, we've done the same thing. We use an address starting with the number 10, But it's the same exact idea. So we took this guy out of rotation. And then if we wait enough hours, students go to sleep, they get disconnected, they close their laptop. So after several hours, essentially no one is connected to that VM anymore. And no one can physically connect to that VM from the outside world because the load balancer is no longer routing traffic there. So then we shut down the VM, power off the machine, pull it out of the rack, put more RAM in, push it in, put the config file back the way it was. Voila, now new traffic will go to this VM. Yeah?
So is it a useful analogy to say that the load balancer acts like a home router doing NAT?
It does. So NAT, network address translation, it's similar in spirit, but it's not the proxy that's doing NAT. We have another device on our little network that's actually doing NAT. However, as in we have another router in the picture that's not pictured here. This guy doesn't need to know that NAT is in use. He just has to have an Ethernet card with an IP address on that same segment in this case. And even that's a bit of a white lie. You can use HA proxy across the internet. So in theory, we have contingency plans whereby if we ever had significant load on our own VMs, we have an account with Amazon EC2 where we could fire up VMs there, and we could, without you even knowing, unless you started poking around, route your inbound connections to Harvard's campus back out to Amazon EC2, their cloud service, where you would see a very similar cloud environment. Yeah.
So if HTTP is stateless, how does the load balancer know that, let's say, user A comes along and he gets sent to www2? How does it know that for the remainder of his session, you're saying as long as he keeps working, he's going to keep going to the same box on the back end?
So long as the connection is maintained. But the next time, thanks to something like round robin, I might end up on a different machine. Indeed, we seem to have just broken the illusion of the session superglobal in PHP terms. So let's come back to that. So yes, problem. Yeah.
I was just going to mention that the other thing that, the industrial load balancers have is the SSL termination as well. So when you talk about the performance of your servers, you can offload some of that, the crypto stuff to the load balancer itself.
So very true, and we're very excited. We just bought for the course exactly this kind of device so that we don't need to run SSL on our individual VMs anymore. We can put our overpriced SSL certificates in just one place, and then everyone will start making SSL connections to a different device that will do our SSL termination. This is actually a wonderful way of buying specialized hardware whose physical chips are optimized for the kinds of computations involved in SSL, and then you have unencrypted connections between that device and your back-end servers. The idea being, hopefully you can at least trust with higher reliability the people in your own network or the machines in your own network, not so much the internet. But there's indeed a problem here. There's a couple problems. One, if we're using this technique called round robin, where every individual request just gets sent here, 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 and then repeats, that's fine for SSH, because my connection is going to stay persistent, and frankly, who really cares what machine I'm connected to? But even in this course, have we discussed the idea of sessions and the fact that they're implemented by default in files in /temp, which is literally a folder or a directory on a local file system, or more generally hard drive, but that's specific to a certain machine. So this seems to suggest a risk that if I log into my CS75 finance project and then let the icon stop spinning because the HTTP request is done, then I click a link to reconnect to the server. Suppose by chance, 50% probability, I get sent to the other web server this time. And guess what? That guy does not even know I exist because it wasn't in his /temp directory that my session file went. So now I have to log in again. Now suppose I add something to my shopping cart or to my portfolio or whatever, but it's stored in my session, say not just a database. So now I have this inconsistent state across these machines. So again, definitely a problem. Let's solve that in a moment. Other problems with this approach of having a load balancer distribute traffic, which in principle is good because now each of our servers only has to handle half the load, and also if one of them goes down, feels like it's not as big a deal. Now the people connected at that moment in time might get screwed for a moment and they might have to reconnect. Maybe they'd lose some unsaved work, but at least there's a system still waiting for them if they reconnect. But other problems.
No, it's not really doing, it's load balancing in a really dumb way. So it's not really taking account of the load on particular servers. So some servers could be heavily loaded because of what users are doing, and others could be be sitting there fairly idle.
Very good. So round robin is completely ignorant of what's going on inside of those servers. So you might know in a Linux system you can run commands like ps for process list or top to see the processes that are using the most RAM and CPU cycles. Well, the load balancer, at least in this story, knows nothing about those metrics. And so there might be some student doing some crazy computation on one of the boxes because he or she just ended up pseudo-randomly on that box. And so really, we don't want to send 50% of the users to this VM. We want to send 90% of the users to the other VM so as to truly balance the load. So whereas round robin balances load with some probability, it also doesn't even take into account how long those connections have been active, right? If you imagine that just by chance, all of the real geeks who stay connected to the server for hours on end, whereas normal people go and take breaks and get meals and whatnot, if they're all ending up on the same machine, even if no one person's really consuming cycles, it could just be the aggregate of a lot of users ending up there. So in general, round robin's great because it's so simple, and on average it probably works, but it doesn't handle anomalies or even common occurrences like people churning through extra CPU cycles. So there do exist techniques, but the load balancer has to know about it, where there is more of a relationship bidirectionally between these devices, whereby the load balancer might every few seconds do the equivalent of pinging the back-end servers and say, what's your load? How many users do you have? Or something along those lines. And it can then use that in its decision as to where to send a particular user. But I'd argue there's still a problem here, and it relates to this idea of redundancy. We do have redundancy, dub 0 and 1, or login 0, login 1. But what's not redundant in this picture? So the load balancer, right? I preach that this is great. We have redundancy. I can sleep through machine failures, but not all machine failures, right? If the single VM we're using right now running this load balancing software itself fails, now everyone's kind of screwed. We might have our backend VMs up and running just fine. They might be waiting for connections, but no one can actually reach them. And because we use NAT, network address translation, internet users can't even reach these VMs via the internet by their IP addresses, because those IP addresses that we're using are private to Harvard. So we seem to have not designed this very well at all if we can in fact lose the load balancer. So let's fix this problem, then dive into this issue of session management. It turns out that what if we just eliminate this load balancer in the first place, right? If the problem is that we don't have a redundant load balancer, well, to hell with it. Let's just take it out of the picture altogether. So how could we do this? Well, you proposed a moment ago that we could use DNS, and in fact we can. If we know that we have multiple backend servers for SSH and web, maybe let's not use NAT for them. Let's actually give them some public IP addresses, and let's use a load balancer that's existed since the first week of class, namely DNS. Right? Recall that DNS can, in fact, return any number of IP addresses for a given host name. And the DNS server itself can implement a method like round robin or some other heuristic whereby every time it's asked a question, what's the IP address for google.com? It can dish out this IP address, and the next time this one, and the next time this one, realizing that those answers might get cached, but at least in the long run on average, we'll be reasonably distributing load across IPs. So if we really wanted, we could change this picture and start calling this a load balancer really just the course's DNS servers. We happen to use GoDaddy's built-in DNS servers for our own DNS. We could just assign to cloud.cs75.net not one IP address like at present, but 2, or even 3, or 4, and each of those IPs simply maps to a different VM. So an upside of this now is what, to be clear? What's that? So cost, right? I can return the device we just bought, right? So what's another upside? No one single point of failure. Now, the DNS servers could fail, though frankly, if the DNS servers fail, well, then no one's really going to be able to reach our servers anyway, and so at least we've kind of put all of our eggs in a basket that was already problematic, potentially. And even then, DNS is meant to be redundant. Any domain is supposed to have at least 2 domain servers. There are multiple root servers in the world, so at least the world's designed that one reasonably well. What are some downsides of this DNS approach?
There's no communication or state in terms of loadness.
Right, so there's no bidirectional communication between the thing doing the load balancing, whether a device or DNS, and so we definitely can't take into account load or other heuristics like that. Yeah?
You can't take a machine out of service.
yeah, now I've created a problem for myself. I really wanted to upgrade that RAM tonight. Well, sorry, there are thousands of computers on the internet that have cached that IP address, and they're going to be hitting you for the next, say, 72 hours. Or even if the TTL, time to live, was configured as less, in practice, it might not be that high. But again, we've discussed the idea of caching issues when it comes to DNS. So not ideal if other people might remember this. Now, I can push back. Thanks to virtualization, or thanks to the fact that computers can have multiple Ethernet cards, in theory, I still can take this guy out of rotation. I just have to reconfigure the other guy to listen on both IPs. But then this is it's a minor headache, if nothing else. It's perhaps certainly not as easy as editing a single text file as I did before. Now I have to actually restart the network interface and all this. It's a little different, but it's possible. Any other downsides that come to mind? That's actually not bad. Actually, and I don't have a screenshot for this. I should mention there's one other load balancing approach. Actually, let me see if I can simulate it. Watch this. Anytime I do something spontaneously, it never works. But let's try this. www.dominoes.com. Oh, damn it. Didn't work. I think they actually fixed this recently. They changed their sauce and also their website, and neither is very helpful anymore. OK, so I'm going to fake this. So the last time I wanted to do this demo, Domino's was a good website to pick on. It's perhaps the wrong thing to do at like 6:30 p.m. here. But so Domino's was a good website to pick on because they were, by contrast, so quick change of approach here, they were not using layer 3 or layer 4 type load balancing at the network layer. They were essentially using layer 5 or layer 7 load balancing, which means it was application-oriented load balancing. And by this I mean when you visited www.dominos.com, as best I could tell, they had some PHP file or whatever language choosing or sending an HTTP redirect, so a location : header, and they would send you to a server called www.1.dominos.com, www.2.dominos.com, www.3.dominos.com. So this is sort of a poor man's approach to load balancing. It's, it's 1, 2, 3 lines of code in PHP or whatever language, but let me simulate so we have someone to pick on here, even though it's no longer really fair. So I got redirected to that URL. Critique this now. Why is this perhaps not the best approach to load balancing? All right, so users aren't going to type that in. But I'd argue that's good, because now people will go through the www entry point that I want them to. What's that?
They can create a shortcut.
Yeah, so what if someone, some non-technical person especially, doesn't think twice about bookmarking this? Well, now that user is always going to try to reach www.3.dominos.com, even if we eventually fix this stupid design, and then we now have people with dead ends who then claim Domino's hasn't been working for me in weeks. Right? There are some people who would assume websites down if their bookmark's no longer working. So that feels suboptimal. Other downsides? Frankly, I should have started with this one, because there's just no reason to do it this way. There are other, more elegant solutions. And we haven't found the perfect one yet, but we'll get closer. Yeah?
Well, you mentioned before about the session. So I don't know, in this case, if your browser died and you came back and you wanted to pick up your shopping cart and you got redirected somewhere else.
Yeah, so that's actually true. I never thought to try that out when it still was this way, but sure. So if you, so your browser crashes or something silly, and you've just added like a crazy big order for some football party, and you really don't want to go through these steps again, your browser session dies, you then reconnect to the website. Suppose you end up on www.4. I mean, you now have to start all over if the implication of being on a specific web server is that you're also using its /temp or equivalent implementation of session. So that also feels suboptimal if the session really is tied to just one machine that you might not end up on the next time around. So let's now reverse from there and go back to the story we were telling, which here involved a moment ago DNS. Just to put this into technical context, we talked about A records a while ago. Well, essentially, a lot of DNS servers on the internet use free software called Bind, Berkeley Internet Name Database, where there's a config file that, along with some curly braces and other syntax, essentially has line after line like this. So updating your DNS records really boils down to just adding another row like this. And this is currently, I think, the 4 IPs that www.cs75.net actually owns. It's accessible on all 4, or it owns all 4 of these IPs. And so this would be the round-robin approach to using a standard DNS server to dish that out. All right, so what about the problem of sessions. So to be clear, the problem right now is if we are load balancing users across multiple servers, and on each subsequent request, especially for HTTP, they might be sent pseudo-randomly, round-robin, whatever, to a different server. Well, they might not get their same session. So what are some possible solutions to this? Yeah? All right, so we could have a shared database. And it turns out at least PHP actually comes with built-in support for using MySQL or another database engine as a backend for the equivalent of /temp. The idea here being, so long as all of your web servers can talk to that database, not unlike our topology in E75, then at least your session data is stored in a central database. All right, so let's assume that we never solve the problem without creating a new one. What's the new problem we've just introduced there? Right, so now if we start with the simplest approach where we just have a single database, which in fairness is what we use for E75, a single database because it's relatively easy to implement and it's quick to fix at least if we have problems, we have now lost the advantage of redundancy in our web servers. So we can still tolerate failures of the web servers or SSH servers, but not now the database, where at least before we had distinct /temp directories. So it turns out, and we'll get to this story today too, we can certainly have redundancies in the database. What else could we do that might not involve a database? OK, so we could load balance based on cookies. So maybe I could, when I see a user gets a big random number as their cookie, as we discussed in the context of PHP and also Firesheet most recently. So maybe I could come up with some arbitrary heuristic. If someone's cookie starts with 0 through 5, I'm going to send them to this box over here. And if it starts with 6 through 9, I'm going to send them to this box over here. It's relatively easy to implement. The load balancer can just look at that incoming request. So that's quite possible. That would work. And in fact, a lot of the commercial load balancers, whose brands we'll rattle off in a moment, that's actually how they do it. They insert into all inbound and outbound HTTP requests cookies of their own that were not sent by the server, that were not sent by the client, but it inserts them sort of as the middleman to keep track of who should go where. What else could we use to decide how to send a given user to the same box again and again, thereby taking a step away from round robin? Besides inserting a cookie, what else could we do? Ideally, I want something that'll work for SSH too, just so that this generally applies. Yeah?
We had a load balancer where if it was a session-based application, we keep track of where the user came from.
OK.
Say it's a sticky session, so you would always send them to the same server for a certain period of time.
What do you mean by where they came from?
Just their IP address.
Perfect. So rather than come up with some hack involving cookies, which again is what a lot of these devices do to be independent of IP, we could just look at the source IP. And we can just take a hash of their IP address and then use that to go to login 0, login 1, login 2, login 3. And in this way, at least we get the same users on the same devices. If the hash function's relatively good, at least we'll get a round-robin-like distribution across the servers. And in fact, that's what we do on cloud.cs75.net. It doesn't so much matter for this course because almost everything we do in this course is stateless, namely HTTP. In the other course, we use the cluster for the students tend to run a compiler and a debugger at the command line where you want to connect to your own process on the same server. So if a student accidentally gets an SSH window here and over here and is trying to debug a process that's running here from this computer here, it's just not going to work because the process ID doesn't exist on both servers. So we use source IP. So there too, we sort of risk skewing the load on the two servers. But again, the theme here is trade-offs. Ease of implementation, definitely one for us there. All right, so what are some other approaches? Well, we don't have to introduce a database. We can actually still keep things in /temp. We just need to back /temp with something fancier than the local hard disks.
Yeah, I was going to say, can you use some kind of distributed storage solution and Symlink to it?
I did leave a question mark. So the answer, though, is yes. So in fact, a common approach, too, is if you don't want to go the database route for whatever reason, really you just need some shared storage. And by this, I mean some hard disk space that's viewable on every system in the cluster. Now, it turns out we, at least in our cloud environment, already have that capability. Your home directory is viewable on either login 0 or login 1 or any other login device that we turn on because we use something called NFS, which has been around for some time in Unix and Linux systems. Even Macs support it. And this is a protocol network file system that allows you, not unlike Windows file sharing, Apple file sharing, and various technologies, to see the contents of some foreign disk as though it were local. So in theory, we can just delete /temp and make /temp we can create the illusion that everything in /temp is local when really the bits are being stored on some foreign server, but the same foreign server across all of our devices. NFS isn't bad. It does have some downsides, among them issues including file locking and the like. It also isn't necessarily and you can use, the upside is most any technology. You can plug an external USB hard drive onto the network, and so long as it can export itself via NFS, you have shared storage, but it doesn't tend to be the highest performing. And so what's the state of the art these days for a lot of people is something called iSCSI, which essentially allows you to implement shared storage over Ethernet, over IP specifically, at reasonable cost. Then there's something called Fiber Channel, which is a less reasonable cost, but tends to be much faster. And so when you allude to a SAN, storage area network, that general technology is often implemented with one or more of these underlying protocols, so that really what you do for your cluster is you got your rack servers running your web servers and database servers and the like. But if you really want a lot of fast, big disk space that's shared across all of these servers, you get a separate device that itself has multiple network cards. It's plugged into your network switch and the like. It's got super fast hard drives, super expensive hard drives, and all of your important data or all of your crucial data lives there and is shared via the network. Yeah?
And how do you, I'm assuming you tell PHP or Apache or whatever root, like the comp files, how to.
Lower level, actually. This would generally be an operating system thing. So I would tell Linux how to connect to that server. Using NFS is generally pretty simple. Install the right built-in package, change a couple of text files. For something like iSCSI and or Fiber Channel, you generally have specialized hardware, like an iSCSI card or a Fiber Channel card that itself has driver software that knows how to talk over that interface. But the high-level stuff that we focus on in the course, like PHP, MySQL, they don't have to know about any of these implementation details. This is an OS layer thing for the most part. All right, let's take a 5-minute break. All right, so how then to implement load balancing? So it turns out there's a lot of options to varying degrees of ease of implementation. So as I said, we currently use HA proxy. Free software, documentation's kind of so-so. It's essentially a huge text file. That's the documentation. Though frankly, once we figured it out, it's mindless to use. We literally change one line of config anytime we want to take things in and out of rotation. And in fact, it's really enabled us to implement a pretty nice topology. Not to dwell too much on the cloud, but only because it's fairly representative of a decent design. We again have these two login servers that run SSH and the like. They NFS mount your home directories. The web server is actually completely separate. So even though cloud.cs75.net is where your SSH connections go to initially, and it's where your web requests on port 80 or 443 go to initially, HA proxy then dispatches those requests based on those destination ports to any number of different machines, either the two login machines, or we sandbox the web traffic and the MySQL database on a different VM altogether that we call LAMP1, Linux Apache MySQL -1, if you've ever looked at the host name of this machine in some form. And so it is nicely isolated from everything else. The idea there just being we don't want students' errant code on one of the login boxes to take down not only that box, but also the database server, also the web server. And it also allows us to run different versions of the operating system software and other such tools so that we can pick different operating systems or versions based on the code that's most important to run there. What's nice about this, though, too, if we wanted to have a second or third or fourth web server, it's the exact same idea. We just tell HA proxy that there's yet another web server or more in the mix, and it will start doing the load balancing for us. Back in 2 years ago when we used Amazon EC2 for one of my classes, it was a little harder to implement load balancing in the cloud. Nowadays, Amazon tragically implements this for you. It's just a feature you pay for. At the time, we had to figure out how to roll it ourselves. But LVS, Linux Virtual Server, is a popular option with which you can do network layer load balancing. Then there's a bunch of other options. Purbal, or Purbal, which is essentially a Perl script that can do this, I believe. Piranha, which is something that used to, I believe, come with Red Hat and its variants. Pound and UltraMonkey, these are all free software-based solutions. If you're ever shopping around for something like this, though, personally, I would absolutely start with HA proxy. We are now huge fans, and ironically, the load balancer, even though it is the single point of failure in the current topology, it is the one VM that we've never had any problems with. It's always the login servers or the web servers that are freaking out for some reason. In terms of hardware, you have some options. So Barracuda is one that I've personally used, and we have a couple of their products now for the course. They provide a whole slew of options. Frankly, based on my playing around with them, they're sort of enterprise-level Linksys boxes, like home routers that are just higher performing, more features, the SSL stuff, for instance, and they're meant for sort of enterprise environments, and they're relatively inexpensive. The three leaders in the space of load balancing, though, that the big players out there tend to use, the biggest websites, Cisco, Citrix, and F5. But to put this into perspective, for a device from any of those three companies, you'll generally spend at least $10K, maybe $20K, literally up to $100,000 for a load balancer, which is really painful to pay when really all they're doing is selling you a hardened version of Linux, which means they generally turned off some services and some other such things, added some of their own software that does load balancing. So HA proxy, frankly, free versus not free, it's pretty darn compelling, even for an enterprise environment. So I would certainly start there if you ever need to deploy something yourself before you start to spend any money. Any questions about load balancing? OK, so now we get to talk. So now let's assume that we have or don't have a load balancing solution. We've decided to focus instead on really improving the performance or the scalability of our system by focusing more at the software layer. And so we can now revisit this issue of caching that we alluded to before in the introduction about the panel involving MySQL and YouTube and Flickr and Facebook and the like. So what are the candidates for caching? So one, we've been using PHP a whole lot in the course. Surely we could start caching the output rather than recomputing the same damn page again and again and again. So there's an opportunity perhaps there. Turns out in MySQL itself, if you are selecting the same data again and again and again, you can tell MySQL to please remember my recent inputs and outputs. And if I ask the same question again and those tables or those rows have not changed, just give me the same answer without even looking in the database for those same answers. For tables that involve thousands or hundred thousands of rows, this can very quickly become a huge gain. And realize, too, lest you think that, wow, I mean, in this course, none of my tables have ever had more than a few dozen or a few hundred rows. It doesn't take all that much effort to write programs or projects that start to involve tens of thousands or hundreds of thousands. Case in point, this is a silly little play application that we implemented a while ago. But if you go to tweets.cs50.net, this is an aggregator of all of the tweets made by people we know about, Harvard affiliates on campus. And at the moment, we're up to 110,944 tweets that have been uttered by Harvard affiliates over the past year or so. And yet the site is actually still pretty performant. You can search across all of these tweets in just a few milliseconds. And this is just a MySQL table that's storing all of this random chit-chat, for better or for worse. So realize, too, even though a lot of the projects we've been working on are fairly small in terms of their scope, it's not hard, certainly given the amount of data just available to us out there in various forms, to really start needing to make some smart design decisions with tables. And then we have opportunities with regard to something more sophisticated like memcached. So this is kind of a fun one to pick on, or in a good way, because Craigslist is familiar to most all of us. It's really not the sexiest website by any measure. They've really not rolled out any features since like the late 1990s. But it's still hugely popular. And would you argue that it's mostly read-heavy or write-heavy? It's probably read-heavy, right? Again, some crazy people that probably post a whole lot, a whole bunch. But generally, if you're looking for apartments or jobs or whatever, odds are you're reading or skimming way more articles than you're actually writing. And in fact, Craigslist doesn't make it terribly easy to edit the articles. If you've never posted, if it's still this way, you go there, you post your advert, and you don't get an account or anything like that, user login. Rather, they send you a link, much like Doodle, if you've used that website. And using that special URL, can you then return to the site and change your ad? But odds are this is not a terribly common case. When you've posted an apartment, odds are if you're a realtor, you're posting the same damn thing again a few days later. You're not going back and changing those ads, since really Craigslist prioritizes freshness. You see the most recent posts first, and so people tend not to go back, I suspect, to change older older things. But notice this too, their URLs, and this is just some random ad I found advertising something germane to the course, PHP and MySQL. Notice in the URL, even though it's a little blurry, the URL, this is kind of passé these days, ends in what extension? So .html. So it turns out that web servers, whether it's Apache or IIS or Lady or Nginx or any of these commercial or free web servers, they're really good in the year 2010 at serving up what kind of content? So static content like HTML, really good at serving up GIFs and JPEGs and HTML files. Why? Because it requires no thought whatsoever. You just open the file, you start reading the bytes, send them out on the network, done. Right? You need very little special software to do something as simple as that. And if you're smart enough, you can cache some of those bytes. You can keep the most recently accessed files in RAM to optimize common JPEGs and the like. Well, so what it looks like Craigslist is doing is when you submit one of these posts, and it's been ages since I tried to advertise something for sale in here, but you are told, I think, your post will appear within a few minutes or by tomorrow or something like that. Well, why might that be the case? Well, presumably Craigslist has a database of some sort in which they store things. Maybe it's MySQL, PostgreSQL, Microsoft Access, whatever, but they're presumably storing this data in a database. But what are they probably doing on some periodic schedule? Writing the information out, right? When you visit the listing of all of the current jobs or whatnot available via Craigslist, you probably are seeing an HTML file that's generated once a minute or once every 10 minutes or once an hour, whatever the schedule is. But if they recognize the fact that most people are just reading ads, not actually posting them, and in a typical bulletin board, we only get a post per hour, a post per minute, not 1,000 posts per second. Well, we don't have to dynamically generate a page thousands of times per second or even more than just once per minute. And so they took the very sort of low tech but pretty darn compelling approach here of just using their dynamically stored data, dynamically generating a page, and then voila, that's it. We're done with this page, unless the user actually edits it, which is really the corner case, or someone posts something new, but even then we just have to update the index. And so that's pretty compelling. Downsides then of this, yeah. Oh,
well, so when you search, according to some keywords, you're still searching a database, but it's just then finding the files.
Presumably, right. So they do have a search box. So if you search for like Cambridge apartment, enter. They do a horrible job searching anyway, at least thanks to the realtors who put Cambridge in every listing. But presumably, yes, they're using a database for the search. The database probably just has the paths or the names of the files in which those records are actually stored. They're probably doing something along those lines so that they can support searches, but at least for the browser, the browsing person, they don't have to query the database at all. Could be. This is really conjecture, inferring based on the URLs. Frankly, these days, web servers are fancy enough that even though it says .html, that could really be .aspx or .php or .whatever. File extensions can be misleading, though. Why would they do that? It probably wouldn't. It's probably an HTML file somewhere. So another a downside of this approach, then? There's the searching issue. They seem to have solved it somehow, but other gotchas? Storage, what sense? Yeah, so that's actually a really good point, right? So there's a lot of structure to these Craigslist pages, right? They all have the same header at like the top left there. They've all got this very elegant avoid scams and fraud by dealing locally exclamation point in red font, right? So there's a lot of shared information. There's a little like table of contents or something at the top right there. And the implication, though, of using HTML is that every one of these like 1990s HTML tags is being stored not once in some PHP file or equivalent, but once for every single HTML file in every post. So here is the theme of trade-off, right? We might be getting better performance in that we don't have to hit a database as often. We don't need as fancy a database, but we need 10 times as much disk space. Now, is that such a big deal? Well, a gigabyte hard drive is pretty cheap. A 100 gigabyte hard drive, also pretty cheap. A terabyte hard drive, still pretty cheap. So maybe we're within an order of magnitude of our comfort zone here, but it certainly is a gotcha to this. Other downsides to pre-generating all the pages like this?
If I wanted to go back and edit that, I gotta write it back out again.
Yes. Suppose they change this tacky little announcement at the top, or they decide to finally make their aesthetics pretty, right? They have to redo all of their HTML, all of their CSS that's embedded in these pages, and they have to regenerate all of their pages. Now, is that a big deal? you know, frankly, maybe it's not a big deal if they just wait till overnight. They regenerate 100,000 pages. It would probably take a few minutes, but once it's done, it's done. But again, it's a trade-off. You're not just going to go into one single file, .php, and edit this instantaneously as you might, as we've been doing for projects. So some upsides and some downsides. All right, MySQL Query Cache. This one's actually pretty easy. If you want to turn on MySQL Query Cache, turn on MySQL Query Cache by adding this line of config in a file called my.cnf, which if you've been using XAMPP or similar, is the file name you use in /etc or whatever to configure MySQL. And this will inform MySQL that you want to start remembering things, recent queries that have not, whose answers will not have changed. This sounds too good to be true. What's going to be the hidden cost here? Have to check whether it's changed. Thankfully, MySQL does that for you. So you do not have to worry about that detail. Oh, yes. So agreed. So the database now has to keep track of which rows have been dirtied, so to speak, been changed in some form, so that it can then forcibly expire this cache. Other downsides? Extra storage, right? So same gotcha as with Craigslist. If you want to have a query cache, OK, fine, you have to put it somewhere. That's either in RAM, which is going to consume bytes, or on disk, which is going to consume bytes. So that's up to you, too.
If you have to restart the server, the cache presumably is
Yeah, so there's that gotcha. If you restart the server because you make some upgrade or you make some config change or something crashes and you need to reboot it, you might lose the cache. So maybe short-term downside, presumably the cache would be built back up, but it's an implication.
You need a replacement algorithm. If the cache memory fills up, you know what rows will stay.
Yeah, so what if it's non-obvious which queries should actually be cached? Suppose that, and I won't try to come up with some cheesy example, I'll just describe the symptoms. Suppose that the load on your server is such that you get lots of requests, but lots of different requests. And you don't get the same request again and again and again. It's not some popular website where everyone's visiting the same news article for some breaking news. They're visiting every single article that CNN.com, for instance, published today. So you don't necessarily get locality of requests. And so you might be filling your cache and then throwing those cached results out to fit the next page, even though had you waited 1 second longer, you would have been asked for the same page again. So, and this is something you, the developer, don't necessarily have control over, but it's an issue with caching just in general. All right, so what are our other options? Well, memcached. So here's some actual PHP code, just to give you a sense of how relatively simple it is to use. The context is, if you've just used PHP to generate a whole bunch of HTML using print or echo or anything along those lines, if you can capture all that HTML inside of a variable, you might as well store it into a cache. Or if you've just, for instance, queried a database and you've asked for all these details on users, their user ID, their username, their cache balance, their portfolios, all of this stuff, and you don't want to have to ask the database for some of that information again, similarly can you put not just HTML strings, you can put entire PHP objects into this kind of database, so long as that object is what's called serializable, so long as it can be represented as a string and convert it into some standard format. And so the PHP code with which you can do this is essentially the following. It looks very similar to a MySQL connection. This first line of code there, again, PHP comes with almost every function built in, at least if you've installed the right module. memcache_connect, you specify the host and the port. You then execute memcache_get if you want to look for a value by some key inside of a cache. Here I'm trying to get back the user whose ID is $ID. And if I get back null, that means it's not in my cache, which means now and only now am I going to jump through hoops, query the MySQL database, wait a few milliseconds to get back the response, and then I have the user object, at which point, you know what, so that I don't have to jump through these steps again, I'm going to cache that user object inside of the memory cache, which ideally is resident in RAM, so I don't have to trouble the database. So to be honest, in terms of database design, or rather, in terms of project design, touching the database as little as possible is generally a good thing. And in fact, in that MySQL panel, if you decide to pull up the video, one of the themes that might come across is that even though you might have a lot of database servers, it's even better to have even more cache servers so that you can avoid the most expensive operations. And the same is true even in smaller scale environments. Ideally, you want to avoid touching disk as much as possible. You want to try to keep everything in RAM. And so this is why, for instance, all of our cloud servers now have 48 gigabytes of RAM, because ideally, we want to be able to keep things like your home directories and your files, and all of that is in RAM, as resident in RAM as possible, so that everything feels as zippy as possible. And we can do that thanks to some virtualization techniques. So any questions on my Memcached? Wonderful tool. I mean, if you have some project at work where you just want to introduce caching, at least if you have hooks for a language that you're using that supports it, wonderfully nice to introduce. All right, so lastly, MySQL itself. It turns out that we've talked about the design of tables, and you've played with primary keys, maybe foreign keys if you've used various engines, but there are a number of more decisions that you can actually make when designing database tables that we haven't necessarily explored yet. And as soon as you start storing something as big, if silly, as 100,000 tweets, you need to be a little more careful when it comes to deciding what database engine do you use, where do you define your keys, how should you search this data, and the like. So with MySQL, you probably have realized, or at least seen the slight acronym called MyISAM, which is the default storage engine for MySQL. Storage engine here, as we may have said a few weeks ago, this is sort of the database equivalent of the file system. In an operating system world, we've got things like NTFS and HFS Plus and ext3, ext2, and so forth. Well, in database terms, MyISAM is sort of its format for actually storing data. Another very popular one is called InnoDB, and some of you might have used that for CS75 Finance for the reason that it supports transactions, which is good in that you can now lock data, but on a per row level. You don't have to lock the whole table as you do with MyISAM, which means you can have higher performance, higher throughput by only preventing simultaneous reads or writes on individual rows, not the entire table. Definitely good when you've got big tables with multiple users trying to touch it at once. Turns out there's a few other engines, two of which are listed here. There's the heap storage engine, aka memory storage engine. If you want a table that by design is stored entirely in RAM and not on disk, especially which is good for temporary things, if you just want to temporarily store and search data very quickly, but you don't really care if it's lost when the machine shuts down, you can create a heap table or memory table. Same thing, rows and columns, keys and such, but you can tell the database server to keep it all in RAM. And then there's something called NDB for clustered. So we won't talk about it too much in this course, but MySQL supports, albeit with some complexity, a clustering environment that's even more complex than what we'll discuss tonight, namely master-slave and some replication scenarios.
Can you split tables in a database over different engines?
Yes, within one database, each of your tables can have a different storage engine. So even we, for some of the core stuff, make conscious decisions based on what kinds of applications are going to use that table. Sometimes we use InnoDB for transactions. Sometimes we use MyISAM for performance. Tends to be a little higher throughput for certain operations. All right, so what are really the differences? We won't dwell on too many of them, but this is a chart from some recent documentation from MySQL itself. One of the things we haven't really talked about in the course, but you might have seen some chatter on the Google group, there's this issue of foreign keys. So we've talked about primary keys, which is the field that's supposed to uniquely identify a row in a table. Well, ID is a common one for a user or for a portfolio or something like that. And probably in CS75 Finance, did you have another table that has a key in it, but the key that's a primary key in some other table. So for instance, if you had a users table with user IDs, that's the primary key for that table. But you might have had in another table called portfolios or accounts or something like that. You might have needed to refer to users by their IDs, but in that context of the portfolios, it's not a primary key because it doesn't uniquely identify rows in that table. It happens to identify uniquely rows in the first table. So if you were using a primary key in a second table, in that context, it's called a foreign key. And what's nice about an engine like InnoDB is that thanks to this notion of foreign keys, you can actually create lots of interesting rules. This is the kind of stuff that a DBA, for instance, would do, whereby you can flag certain fields in a table as being dependent on fields in another table. So even without writing any PHP code, you can actually tell the database, if I delete this user, automatically in a cascading fashion, delete all of his or her rows in this other table and this one. So you can create relationships among tables so that really, at the end of the day, your data can be kept consistent without you having to write code or keep track of this. Right? As a programmer, it'd be very easy for me to accidentally delete a user from one table, but forget, oh, there's some data, there's some mention of that user in all these other tables. So over time, you get all this junk building up in your tables. And if nothing else, it takes up space. But worse, it just gets confusing. Like, wait a minute, who was user 1, 2, 3? We have no record of them. Not the best situation to be in. So the database can actually enforce some of these constraints for you. And this little chart here indicates the locking capabilities of these engines. Full text, for instance, is a feature of my ISAM, whereby if you don't want to just search using the like keyword, you actually want to do Google-like Boolean matching. You can declare a full text search field or index, but you can only do that within my ISAM table. So to be honest, some of these come up quite often, and tucking a few of these away in your head is a good thing, but some of the details here are lower level and are of more technical curiosity than day-to-day utility. So how do you actually start wiring these database servers together? So one of the problems we admitted to earlier was, right now, mysql.localdomain, the database server we use for the course, it is a single point of failure, just like the load balancer. Now, we could solve this, but we've chosen in our minds just to choose simplicity over complexity. But it turns out that it wouldn't take all that much effort to introduce what are called slaves into our environment. So here is a very general topology that allows us to have redundancy in our database layer, whereby we have one database server like we currently do. We start calling it the master. And then there's 1 or 2 or 3, for instance, slave servers that are configured to talk to that guy. And they're configured to talk to him in such a way that any time data is written to the master, that data should be replicated to database server 2 and 3 and 4, but not in the other direction. So the idea between master-slave relationships and databases is that the slaves should be read from or written to, whereas the master should be read from or written to, based on that simple definition and those directional arrows. Slaves get written to by the master. And how about my PHP code? To which of these boxes should I be connecting with MySQL Connect? So master for, definitely for reading. How about, okay, I kind of spoiled it. So definitely for reading, let's pretend you say. For writing, let's pretend you say. But how about for reading? So really any of them, but more specifically slaves. So a lot of the scenarios we've described, if briefly tonight, have really emphasized read-heavy sites. And that's kind of the common case, right? Even Facebook, where you have crazy people editing their profiles incessantly, they're not editing their profiles hundreds of times per second, hundreds of times per minute. So even if my obsessive friend updates his or her profile, odds are they're only going to do it every 5 minutes, every 10 minutes. Now, if that person's particularly popular, well, their profile might in fact get read in some form in someone's newsfeed or by pulling it up explicitly in a browser, a few times per minute, which suggests that they're going to get more reads than they are writes, so we should optimize for this scenario. Now, you can come up with scenarios where writes are more common than reads, but generally anything involving humans these days on the web-facing projects, odds are we're reading the data more than we are writing it, at least when there's hundreds or thousands of users in the mix. So slaves are generally introduced to a database layer if you want to be able to handle twice as many, 3 times as many, 4 times as many reads. You can just throw hardware at that. Now, you still have to have a single entry point for any writes so that the writes then get propagated to the so-called slaves. But at least now we can handle many more reads per second. And doing this generally with MySQL involves maybe a couple networking changes, firewall issues and the like, and a couple of lines of config that tell the master to write to the slaves and vice versa to receive it. But there's still a single point of failure there. So let's solve the problem in the obvious manner. Well, if the master is the single point of failure, let's just have 2 masters. And so you can do this too. You can have 2 masters in MySQL and other database technologies talking to one another so that anytime something is written to the master on the left, it is also sent by that guy to the master on the right. And then if you want, each of those masters in turn can still have that master-slave relationship so that your code is designed to read from the slaves, numbers 3 and 4, but any writes should go to 1 and 2. Now, even though in the course we've generally introduced the simplest of PHP's APIs for MySQL, all the functions called MySQL_connect, you can, using even those functions, though it's not obvious perhaps, you can use those functions and maintain multiple database connections. So even in your code, could you get into the habit of using one connection for your writes and one connection for your reads, so you can exercise this control yourself even at the code level relatively easily. And if you wrap things, frankly, in a nice class, you can figure out if this is a select, send it here. If this is an insert or an update or a delete, send it here. So you could even hide the detail from the programmer if you wanted.
So, I mean, I assume you're going to want to cache writes to the slaves, but even if you don't, you could have potential race condition.
So your consistency issue and race, so yes, you do introduce the issue that if you're going to be talking to, for instance, the master on the left with one request, you don't want to, on the very next request, read from the guy on the right. So generally, there would be the notion of partitioning involved here, whereby an individual client or server or program would know which one to actually write to. And the other guy would be used by the other half of the programs or users. But in short, you need to have some determinism here.
I was just thinking about reading from a slave right after you've written to a master. I mean, there's going to be some latency.
So there too, and you can see this. Frankly, I mean, I'll say in my defense, I don't use Facebook all that often, but even I have seen when like refreshing the home page again and again, I get different results on different refreshes, which probably doesn't relate to talking to different database servers, but rather different caches. But yes, that issue does arise when this happens. So what still can be done? Well, how do we actually deal with something like this? Well, we need, if we're going to adjudicate between master 1 or master 2 so that we're talking to the right guy, or the same thing with the slaves, we could hard code this into our code, but generally best if we factor that out, right? We've not been telling any student whose name starts with A through M, please SSH to this server. And anyone who's N through Z, please SSH to this one. It's nice to kind of hide that detail both from the users and also from your own code. So in theory, we could apply some of the lessons from earlier involving load balancers to the same topology. This is a somewhat arbitrary picture, I think taken from one of the textbooks recommended earlier. But you'll notice here that we can use this same black box, we'll call it a load balancer, and it can be implemented in any number of ways that we discussed earlier, but it's generally sort of the HA proxy approach at the networking layer. And we can introduce, for instance, at the top, we had the user, whose arrow is coming from the sky there, talking to the load balancer, getting randomly sent somehow to the web servers. The web servers, meanwhile, need to do reads and writes. For the writes, they're going to have to go through the master. But for the reads, they're going to be load balanced across potentially the slaves down here. And so at least for, again, I'd be wary, for instance, if we were doing stock portfolio updates or anything particularly crucial for something like that, where we want to take every caution to avoid race conditions. There are ways in which we can mitigate that, one of which will be partitioning in just a moment. But certainly for something like Facebook, it seems to be the case that they've made the conscious design decision that if the users see inconsistent state on page to page, it's at least something they're willing to live with right here. And for some applications, that might be fine. Something like a Craigslist or the like, we're not actually losing money if the state is inconsistent briefly. But if we care a bit more, we can implement this approach. And Facebook actually took this approach initially. If you used Facebook a few years ago, you might recall that the URLs were of the form harvard.facebook.com, mit.facebook.com, bu.facebook.com. And the approach Mark originally took, as best I can tell, is that, frankly, with the first school, he probably had his code base and his database server. Then they wanted to roll out to some other school. And the easiest way to do that was just create another subdomain, do cp-r, and recursively copy all the code, make a copy of the database, and then segment or partition the schools in this way. Early on, Facebook limited, you recall, to your own network or your own school. So this was actually reasonable to have everyone in their own little sandbox, but it was also pretty good for performance. It may very well have been the case that everything was still on one server with different databases and different folders of code potentially. But the upside is that you now can, in theory, move mit.facebook.com or bu.facebook.com to different servers, thereby scaling horizontally, so to speak, by just putting them on some other cheap server, but a different server with some spare cycles, without having to touch any of your own code. It's just a hostname trick that would map the users to a different space. And this idea of segmenting your users into different demographics, whether it's based on school or first name or last name or any arbitrary distinction, is generally called partitioning and is generally quite often done in databases when it comes to chopping up your user sets so that you can avoid, for instance, some of the issues we alluded to earlier, race conditions and the like, but can still grow laterally and handle multiple users. But what might a downside be of this approach, of putting, in this picture here, everyone whose name is A through M on the left and everyone who's N through Z on the right?
You have to somehow always make sure that the A through M requests are going against those slaves versus...
Yeah, exactly. The Facebook example is a bit misleading in its simplicity. You know, back in the day, that's kind of an easy heuristic. If you're from Harvard, you go to this hostname. If you're from MIT, you go to this hostname. Better yet, the users did it themselves, or at least when you logged in based on your email address, you could be dispatched a la Domino's to the appropriate web server's hostname. But for a typical application where you don't have the luxury of drawing these very coarse strokes between users, might take a little more work to actually partition your users in this way. But I think this is not uncommon even for something like Exchange, at least in prior versions, where some users would be on this server, others would be on this server, and that would generally be done based on, say, domain name, which is actually perhaps a reasonable coarse measure with which to distinguish people based on what their email addresses end with, not start with. What about keeping these things alive? So the other theme in the world of scalability is HA, like the HA and HA proxy stands for high availability. This refers to not just having redundancies, but also having automated protections in place so that if something dies, something else takes over for it without ideally human intervention or someone waking up. So in this scenario here on the left, we have a load balancer talking to two masters, left and right here, replicating, so to speak, back and forth between the two of them. What many load balancers do, what most load balancers should do, is not just blindly send users to A to B, to A to B, to A to B. Even if they're not cognizant of the load on these individual servers, surely they can be pinging or equivalent each of A and B occasionally to see, are you alive? Are you alive? Are you alive? And the first time that server doesn't respond, it stops routing future people to them. And so that's what HA proxy does for us. In theory, if one of the servers died, it should automatically take it out of rotation because it would stop hearing from it. And so in this context here, you have not only redundancy, but at least at the database layer, thanks to the load balancer pinging or equivalent to servers, you can also have high availability, which means one of those can go down in the middle of the night, and the system is designed in a way where the other guy can just take over. And there are more sophisticated approaches still. I referred earlier to the idea of taking a physical server out of rotation and then just giving his IP address to another server. You can do that manually with a few commands in a Linux environment, but you can also do it automatically. If you have the right script or the right tool, you can just tell the database server on the left, take over this IP. And so some implementations of this idea have what might be called floating IP addresses, where really only one of the servers is in use at any one time. Only one of them has a real IP address that machines are talking to, but the moment number two realizes number one's heart has stopped beating, so to speak, or vice versa, he assumes his IP address and then starts receiving, just taking off the internet, off the networking cable, any requests destined for that IP address. So it's a little more forceful. So heartbeat, too, is the other jargon that comes up in this context all the time. Any questions? I can't tease you with the surprise ending, because that was it. But any questions on partitioning? All right, so keep this in mind at least moving forward. So with regard to the final projects, odds are you're not going to have hundreds or thousands of users banging on your server at once. But certainly if you start implementing retrieval of data sets like we might do for Harvard Tweets, if you're implementing any sort of project that uses a public data set, or really if you're just trying to really fine-tune your own project's performance, especially as it relates to things like selects, there are a lot of knobs you can turn, even in MySQL alone, to optimize searches with using keys, using full text engines, important. So do consider the final project ultimately not just an opportunity to go off on your own and try things you've already tried in the course. Do use it, as we've said before, with JavaScript libraries as an opportunity to really try something that you haven't used before, ideally something you'll use after the course ends. Why don't we call it a night here, and I'll stick around one-on-one for questions if you have them.